Today we continue with the journey in our solar system, but we won't talk about a planet. We are going to discover our satellite, the Moon. Still today, there is some uncertainty on the origin of the Moon, but we are quite confident in discarding the hypothesis that it was originated by detaching from Earth, in particular from the Pacific crust. This is only 200 million years old and without any sign of a detached body. Moreover, the chemical composition of the Moon is quite different from the one you could find somewhere on Earth. A recent suggestion is that Moon formed in the protoplanetary stages of Earth itself, when a collision caused a massive ejection of material. Then gravity did the job. As you may know, it is the only Earth's natural satellite, and its orbit has a mean radius of 384,000 kilometers, being almost circular. Very interestingly, Earth and Moon are tidally locked. Their rotations are so synchronized that we only see one side of the Moon independently from where on Earth we are looking. Indeed, Moon needs the same time both to rotate around its axis and around our planet, and humans didn't see the lunar far side until a Soviet spacecraft flew past it in 1959. Today, more than 105 robotic spacecraft have been launched to explore, and it is the only celestial body beyond Earth visited by human beings, so far. By looking directly from Earth, dark and light areas are visible without the need of a telescope. Therefore, humans have always been able to observe the Moon with a high enough level of detail and called the lighter regions seas. These areas are in fact uplands. If you were wondering, there is no liquid water on the Moon, even if some water ice has been found near the South Pole. All the observed craters are meteorite impacts, even though there is quite an active tectonic activity, the moonquakes. After Earth, the Moon is the best known celestial body to humanity. Since the first landing of Armstrong and Aldrin on July 1969, more than 2,000 samples have been collected from the surface. Studying the lunar surface became quite important for NASA in the 60s, such that the initial objective was to conquer the Moon before the Soviet Union. But then they started to think about sending astronauts that were not experimental test pilots, but scientists, to better study environment. Quite significant is the case of Harrison Schmitt, astronaut part of the Apollo 17 mission, who was the last man to be on the Moon, and who worked for NASA mainly as a geologist, not as a pilot. In fact, we know something of the lunar surface since 1959, when the Soviet unmanned rover Luna returned about 300 grams of lunar soil. After some years, Apollo astronauts placed instruments on the surface which kept working for almost a decade since then. Among them, there were seismometers which detected moonquakes and meteorite impacts, as well as passive laser reflectors which made possible to exactly measure the Earth-Moon distance. These reflectors are still used today. Thanks to seismometers, we know that moonquakes take place at a depth of 800 to 1,000 kilometers, considerably deeper than earthquakes, and they are also much weaker than on our planet. Most of them occur with monthly periodicities and are related to tidal stresses caused by the eccentric orbit of the Moon about the Earth. By studying the transversal S waves, we know that they cannot penetrate the asthenosphere, indicating that it is at least partially molten. By observing the Moon from a higher perspective, thanks to the orbiting, this time, artificial, satellites, we also know that not all the lunar material was originated on site. Indeed, mascons are mass concentrations basaltic blocks that are supposed to have formed after huge impacts which produced the Maria. The impact craters must then have been filled with the lava flown from the craters themselves. About 4 billion years ago, the number of meteorites that impacted the lunar surface must have been sensibly higher, and we think that this must have been the time when the most craters formed. Since we mentioned lava and craters, maybe you are wondering what's below the surface of the Moon. Moon's mean density is 3,400 kilograms per cubic meter. Looking from the center to the surface, we find the iron core, which is 240 kilometers in radius and is solid. It is surrounded by a liquid shell, still made of iron, up to 330 kilometers of radius. Here pressure decreases and so the temperature, consequently the next layer, extended up to 480 kilometers, is only partially molten. Reaching the surface, we find it covered by a layer of soil with scattered rocks, the famous lunar regolith, which is mainly what is left of the meteorite impacts. The thickness of regolith is estimated to be in the order of tens of meters, so that the original surface is nowhere visible. Like submerged by this material, you can find a special type of rock, the breccia, which is a fragment of different rocks compacted and welded together by meteor impacts. The maria are mostly composed of dark basalts, which form from rapid cooling of massive lava flows. The highlands are largely composed of anorthosite, an igneous rock that forms when lava cools more slowly than in the case of basalts. But now comes the interesting part. We know from data by the Lunar Prospector and the Clementine spacecraft that Moon has water in the surroundings of its poles. Clearly, due to extreme temperatures, it is in the form of ice laying under the regolith. As you may know, on the exposed surface of the satellite temperatures are extremes in both senses, hot and cold, varying from -150 degrees Celsius up to +120 degrees Celsius. Ice is mainly distributed in regions where valleys are present, projecting a permanent shadow on the regolith. In the previous number of the SpaceInfo newsletter, we talked about our home, planet Earth, and in the end we talked about the magnetic field and Van Allen belts. Do you remember? Have you read the article and watched the video on our YouTube channel? What about the Moon? Does it have a magnetic field? By data we know that the lunar magnetic field is very weak, if not completely absent. The very small amount of a magnetic field remnant probably is the indication of a more intense core activity in the past. Another notable absent in the lunar scenario is the atmosphere. Technically, it is so thin and rarefied that it has been labeled as an exosphere. In the same way we have seen for Earth, this exosphere is the point of contact between Moon's surface and space. Now you have probably an idea about what happens if a celestial body doesn't have an atmosphere and a magnetic field. All particles thrown by the Sun and transported by the solar wind are free to reach the surface and ionize the regolith, as witnessed by the samples retuned with the Apollo mission. However, a stronger witness of how strongly is regolith ionized can be given by the spacesuits returned from the human missions. But this is another story. See you in the next video.